Today I'm talking about electric field of a sheet of charge. In previous section we defined volume charge density and line charge density. And volume charge density describe the volume charge distribution. Using volume charge density, delta Q is rho V multiplied dV prime. dV prime is differential volume. For line charge density, delta Q is rho L dL prime. In previous section, this is rho L dG prime, rho L dG prime. The electric field in volume charge distribution is integral is rho V dV prime over 4 pi epsilon 0 r vector minus r prime vector square. R vector is field position vector, r prime vector is source position vector, and the AR vector. And for line charge density, the electric field is integral rho L dL prime, and line charge is located in the axis. This is d prime over 4 pi epsilon 0 magnitude r vector minus r prime vector square AR vector. So this unit of volume charge density is coulomb per meter cubic, and this is coulomb per meter. It's 1 dimension and 3 dimension. And today I'm talking about sheet of charge. To describe sheet of charge, we need to define rho S. This is surface charge density. The unit of rho S is coulomb per meter squared. This is 2 dimension because rho S is for 2 dimension. This is the charge is located on the plane, and this charge consists of many line charge, and the surface charge consists of many line charge. So if we try to find electric field some point P, and total electric field is the sum of the electric field for each line charge. So for example, we talking about symmetry of surface charge. Consider infinite sheet of charge is located at 2 dimension YG plane. It means this is Y axis, this is X axis, and this is Z axis. The charge is located on YZ plane, and YG plane consists of many line charge, and this line charge is symmetry in Z axis. For example, we consider this line charge and this line charge is symmetry. This line charge is symmetry as the axis, and this minus Y prime. This distance is Y prime, and this 0, minus Y prime, 0. This point is 0, Y prime, 0. We try to find electric field at this point, and electric field by line charge 1 is this direction. This is low direction in line charge 1, and this is low direction in line charge 2, and total charge is the sum of this electric field and this electric field, and total electric field and x direction. For every symmetry line charge, the direction of electric field is x direction, right? So total electric field direction is x direction, and this is perpendicular to YZ plane. So in summary, since symmetry exists, only electric field of normal component means perpendicular to the plane YG plane. The only normal component exists. It means in this case only x component of electric field exists. The total electric field direction by a surface charge is perpendicular to the plane. So if we try to find electric field like this point, the direction of total electric field is minus x direction. So we are talking about how to calculate the electric field in detail. As I said to you, the surface charge consists of many line charge. This is y and x and z. The surface charge is located on yg direction. This is c. This is c. And charge is located in yg direction. And yg direction consists of many line charge. For example, we consider this line charge. And the total electric field is the sum of each line charge, the electric field by each line charge. So this line charge, this is y prime, distance is y prime from origin to the center of line charge. And this distance is dy prime. And we can find electric field point P, x, 0, 0. So we have already known the total electric field component is only x component. The y coordinate and z coordinate doesn't affect the electric field. So I pick up 0, 0, and 0. So electric field direction by this line charge is this direction, because this is a low direction. We call this electric field the DEL vector. But the electric field is only x component. So this is electric field. So we need just the x component of the EL vector. So we let this angle is theta and theta. And DE vector is magnitude of the EL vector cosine theta. Direction is x direction, AX vector. So we have to find the DEL vector. DEL vector is this is the infinitesimal electric field by this line charge. This is rho L over 2 pi epsilon 0 rho A rho vector. The magnitude of the EL vector is magnitude of the EL vector is magnitude of rho L over 2 pi epsilon 0 rho multiply A rho vector. A rho vector is unit vector. The magnitude of L rho vector is 1. So this is rho L over 2 pi epsilon 0 rho. So we input magnitude of the EL vector into the D vector. So the E vector is rho L over 2 pi epsilon 0 rho cosine theta AX vector. We have to find the rho L. We don't know rho L. We know only rho as surface charge density. This unit is Coulomb per meter. And rho S unit is Coulomb per meter square. So to make rho L, we have to multiply dy prime meter, and unit is the same, Coulomb per meter. So rho L is rho S multiplied dy prime, and the rho is, this is x square, square root x square plus y prime square. Cosine theta is x over rho. So d vector is rho S dy prime over 2 pi epsilon 0. 2 pi epsilon 0 square root x square plus y prime square multiply cosine theta is x over rho. Rho is square root x square plus y prime square and AX vector. So D vector is, this is rho S dy prime 2 over 2 pi epsilon 0 x square plus y prime square multiply x AX vector. The total electric field is integral D vector. So total electric field is integral dE vector. dE vector is rho s dy prime over 2 pi epsilon 0 multiply x over x square plus y prime square dy prime ax vector. This is dy prime, this is ax vector. This integration is for y prime. Except for y prime, other characters are constant, so this becomes rho s over 2 pi epsilon 0 integral x over x square plus y prime square dy prime. The lower limit and upper limit is the range of y prime. The surface charge consists of infinite line charge, so y is minus infinite to infinite. So this lower limit is minus infinite, upper limit is infinite. We let y prime be x tangent theta, and we take derivative on both sides. Left hand side is dy prime, and right hand side is x square theta d theta. So this integration become rho s 2 pi epsilon 0 integral. Denominator is x square plus x square multiply 1 plus tangent square theta, and x is dy prime is x sec square theta d theta. The lower limit is y prime. When y prime minus infinite, the theta is pi over 2, and when y prime is infinite, the theta is pi over 2. So this is sec square theta. So rho s over 2 pi epsilon 0 integral from minus pi over 2 to pi over 2. Denominator is x square multiplied sec square theta, and numerator is x square sec square theta d theta. This one. And electric field by the surface charge is rho s over 2 pi epsilon 0 to 2 pi epsilon 0. This is pi, so this is rho s surface charge density over 2 epsilon 0. I omit x vector, and this is x vector, ax vector is ax vector. This is total electric field by surface charge. In this case, yg plane is the surface. So we apply this electric field to the capacitor model. If adding second infinite sheet with minus rho s at x equals a, we have three cases. When the point P is x is greater than a, the electric field at point P. So we have adding sheet x equal a minus rho s, and this x equals 0 rho s. So we have to find the electric field at point P. Point P is greater than A. This is point P. The total electric field is electric field by minus rho s plus electric field by rho s. So electric field by minus rho s is, this is minus rho s over 2 epsilon 0. The direction is a perpendicular direction. This perpendicular direction is, this is x direction, ax, plus the electric field by rho s is rho s over 2 epsilon 0. The direction is, yes, it's the x direction, so the x direction, and this is 0. The second case is the electric field at point P. The point P is between 0 and A. So x equal a, we have surface charge density minus rho s. This is x equal a. We assume a is positive. This is at x equals 0 plate. We have surface charge density rho s. We find electric field is this, and 0 between 0 and a. So total electric field is electric field by minus rho s plus electric field by rho s. Electric field by minus rho s is minus rho s to epsilon 0. The direction is downward direction. Downward is minus ax vector plus this is this, and electric field by rho s is rho s over 2 epsilon 0. The direction is x direction. This is x, ax vector. So this is adding is rho s epsilon 0 ax vector. This is ax vector. The case 3 is when the point P is less than 0, and we try to find electric field at point P. We have minus rho s x equal a plane and x equals 0 plane. We have surface charge density rho s, and we try to find electric field less than 0, and total electric field is electric field by minus rho s plus electric field rho s. Electric field minus rho s is minus rho s over 2 epsilon 0. The direction is minus ax. Electric field by rho s is rho s over 2 epsilon 0. The direction is minus ax. The adding is 0. So we if we have two parallel plates, just the electric field between these two plates only exists, and otherwise the electric field is 0. We take an example. We have 3 infinite uniform sheets. Uniform sheets are located in free space. 3 nanocoulomb at x equal minus 4. This is x equal 4. Plane is located x equal 4, and plane is located x equal 1, x equal 1, and plate is located at x equal minus 4. The plane at x equal 4, the surface charge density is minus 8 nanocoulomb per meter square, and the plane x equal 1 is 6 nanocoulomb per meter square. Nano means 10 to the power minus 9, and the plane at x equal minus 4 is 3 nanocoulomb per meter square. We try to find the electric field at 4, 2, minus 3. And this is C, not X. This is C, and C. C equal minus 3 is this position. So total electric field is electric field by minus 8 nanocoulomb per meter square plus electric field by 6 nanocoulomb per meter square plus electric field by 3 nanocoulomb per meter square. This is rho s is minus 8 multiply 10 to the minus 9 to epsilon 0. And the direction is this direction, minus AZ direction, and plus 6 nanocoulomb is 6 multiply 10 to the power of minus 9 over 2 epsilon, and the direction is minus X direction, minus Z direction, and plus electric field by 3 nanocoulomb per meter square is, this is 3 multiply 10 to the power of minus 9 over 2 epsilon 0. The direction is AZ direction. This is the answer of the question. Epsilon 0 is 8.854 multiply 10 to the power of minus 12 farad per meter. And we input this value into the electric field, so we can get the answer of this question. Today we're talking about electric field by surface charge. As you know, electric field by surface charge is not rated to distance, so it's easier to calculate electric field rather than electric field for volume charge density and line charge density. Thanks for listening this video, and see you later. Bye bye.